Hello everyone, my name is Logan. Welcome back to the lecture hall. Today we're covering section 3.5 of our UCI Math 2A single variable calculus course, Implicit Differentiation. So, what do we know so far? We know how to find these two, right? This first one, really easy, power rule. If we want to find the derivatives, these are easy. First one, power rule. Y prime is going to equal 2x, right? We've seen this derivative in many videos. Okay, but what about this? How do we do this problem? Because it's not y equals anything. It's x squared plus y squared equals 1. We don't have like a definitive, oh, y equals this. Well, what we have to do is we have to differentiate term by term. So what we're going to do, we're going to take the derivative of x, or derivative of everything with respect to x, and we're going to do dx to each term, and that's the same thing as saying dx of x squared plus dx of y squared is equal to dx of 1, right? And so we're going to start at this one because this is the easiest one. The derivative of 1 is 0. It's a constant, obviously. Okay, now the derivative of x with derivative of x squared. Oh, hey, we know it's 2x, right? So it's going to be 2x. You can think of it kind of like chain rule, and then you multiply by dx, right? And then for this plus y squared, it's derivative with respect to y, or derivative with respect to x of y squared. And, well, it's still going to be power rule, 2y, but then we have to multiply it times the derivative of y, right? Think chain rule, how we have to do dy dx. So then we get that, and we're like, okay, and we know that y prime, which is what we are looking for, which is our derivative of y, well, we have it. It's right here. It's our dy dx. So then if we just solve for dy dx, we find the derivative of y. So then let's do that. Well, so we have subtract 2x, and then divide by 2y, divide by 2y. What do we get? Well, we get dy dx is equal to negative 2x over 2y, and that's just equal to negative x over y. And we're like, hey, the derivative of y, dy dx, is equal to negative x over y. And this is implicit differentiation. You have to take it term by term, and every time you have, say, a y, or a y squared, or a whatever it may be, something y, you multiply it by a dy dx. And then also, just a little refresher, dy dx is equal to y prime. Those notations are the same, so for the rest of this lecture, I'm just going to be writing y prime instead of dy dx, but they mean the same thing. So implicit differentiation can help us find things like sine inverse of x, right? We don't know what that derivative is quite yet. I mean, we will in about 2 minutes and 30 seconds, maybe, depending on how long I take to explain. But so, what is sine inverse of x, which is equal to y? How can that be rewritten? Well, it's an inverse function, so we can rewrite it as x is equal to sine y, right? We can, these are equivalent statements, because this is just the inverse of the other. Okay, perfect. And now we can implicitly differentiate this, because we have a sine of y. So then let's do that. Let's implicitly differentiate the whole thing. So, how do we do it? dx of x is equal to dx sine y. Okay, And now let's just differentiate. Well, derivative of x is 1. And well, what's that equal to? Well, it's derivative of sine y. Well, what's derivative of sine? Cosine. Cosine y. And then, as I said, every time you differentiate when there's a y, you have to multiply by y prime, right? Good. And then, so we're like, okay, that works. And then now what we're going to do is we're going to divide each side by cosine y. So then we get this funky thing. We get y prime is equal to 1 over cosine y. But that doesn't help us because we want it in the form where it's like something x. Y prime equals something x. We don't want y prime, we don't want y in on the other side of our equation. So let's kind of just manipulate it with trig that we know. Well, this is the same thing as saying 1 over the square root of cosine squared y, right? Because that's a square root. These two statements are equivalent. And then this is also equal to 1 minus sine squared y, right? And you're probably like, wait, 1 minus sine squared. Well, if you recall from trig, maybe pre-calc, maybe geometry, we have this trig identity that states sine squared x plus cosine squared x is equal to 1. So then if we subtract this sine, we get cosine squared x is equal to 1 minus sine squared x. And then, you know, here we're dealing with y, so we have cosine squared y, that's equal to 1 minus sine squared y. Perfect. Okay, now we're kind of getting somewhere because we know x is equal to sine y. And hey, we have this sine y squared. Okay, well this y prime, which is equal to 1 over square root 1 minus sine y, and that's squared, right? Well, we know sine y, that just equals x. So we can just plug in our x into here. And then we get that this is equal to 1 over square root 1 minus x squared. And it's like, oh, hey, now we have something that we wanted. So, for our inverse sine function, we know y prime is going to be equal to 1 over square root 1 minus x squared. And we can do this for all our trig functions. And I'm going to write them out in, a few seconds so you guys can see them. But I want you guys to pause the video and do this for cosine and tangent. And just implicitly differentiate on both sides. And then just work through using trig identities. And you'll get these. But I have written out what their derivatives are. So we already found the derivative of sine inverse x is equal to 1 over the square root of 1 minus x squared. Alright? Derivative of cosine inverse of x is negative 1 over the square root 1 minus x squared. Now, derivative of tan inverse is equal to 1 over 1 plus x squared. Now we have derivative of cosecant inverse of x, which is equal to negative 1 over x times the square root of x squared minus 1. And then we have derivative of secant inverse, which is equal to 1 over x times the derivative of secant inverse is equal to 1 over x times the square root of x squared minus 1. And then finally we have the derivative of cotangent inverse, and that is equal to negative 1 over 1 plus x squared. So these are how you would find your inverse trig functions. You use implicit differentiation. And as I hope you guys can see, this is a very important thing. And this will come back again in like when I cover Math 2D, which is the first part of multivariable calculus. You're going to use this sort of implicit differentiation later. And yeah, so this is all for the lecture portion of the video. Let's transition into some practice problems. Alright, so we're going to be doing number 5, number 12. Number 5. We kind of seen it before. Okay, x squared, there's an x squared, a y squared. But now we have this crappy negative 4x, y. Well, what do we have to do? It's like 4x and y. Well, we're going to have to do that handy thing called product rule. And as I'm hoping you guys are noticing that as the course goes on, each differentiation thing stacks on top of one another. So, like from the previous video, we used chain rule and we had to use product rule inside the chain rule. So, this is what we're going to have to do. We're going to differentiate term by term by d dx. Okay, well let's just write that out. d dx of x squared minus d dx of 4xy plus d dx of y squared is equal to d dx of 4. Well, this first term, easy. We know it's 0, right? Because it's the derivative of a constant. Okay, not too bad. Now let's start over here again. Okay, derivative of x squared. Well, we know that by now. 2x minus. Okay, we're going to put a parentheses. So we have one function, 4x, and then we have one other function, y. Okay, let's just take the derivative of that. Well, first, d last, so 4x times 1 times y prime. Why do I say 1 times y prime? Well, because it's the derivative of y, which is going to be 1, and then you always have to multiply by dy dx, or your y prime. So that's why it's 4x times 1 times y prime. Plus, well, we have our first d last plus last d first, so plus y times the derivative of 4x, which is just 4. Okay, so then I'm just going to rewrite this to be 4y, because that's, nicer to look at, obviously. And then we get, okay, well, what's the derivative of y squared? We know it's 2y times y prime. Okay, so what do we have to do? Well, first we have this parentheses. Let's just get rid of this parentheses and rewrite this so it's a little nicer. I'm just going to erase. So, okay, we get rid of that. We're going to make that a negative because we're getting rid of the parentheses. And then we're going to just rewrite this to be 4x y prime. Right? Because that's the same thing as saying 4x times 1 times y prime. Okay, our next step. We want all the y primes by themselves. We want them all on one side. Okay, so how do we do that? We'll just subtract 2x, add 4y to both sides, add 2x, add 4y. Sorry, it was subtract 4 or 2x. And then what do we get? We get 2y y prime times, or minus 4x y prime is equal to negative 2x plus 4y. Okay, perfect. Now we have 2 y primes and 2 terms. That means we can take out y prime from each term, and we can just solve for y prime. Now it's easy. Now it's just algebra. So then we get y prime is y prime of 2y minus 4x is equal to negative 2x plus 4y. And then we just divide this 2y minus 4x on both sides. And what do we get? Well, our final answer is going to be that y prime is equal to negative 2x plus 4y divided by 2y minus 4x. And that's going to be our final answer. So that's how you do this. It's not too bad. You just do it term by term, and every time you differentiate y, you multiply it by y prime at the very end of that. Alright, so we're going to do number 12, and number 12 looks pretty bad, but it's really not horrible, and it's the same strategy. Just like most of calculus, it's just doing the same thing over and over until you master the problems. So what's the strategy for implicit differentiation? Doing it term by term, and then every time there's a y, you multiply, or every time you differentiate a y, you multiply it by y prime, or dy dx, whatever you prefer to write out. So how do we do it? D dx of e to the y times sine x, which is equal to d dx of x plus d dx of x times y. Okay, well, where do we start? I want to start on this side. This side's quicker. We're going to do the derivative of x times y. Well, it's product rule, so first d last. So it's going to be x times 1 times y prime plus last d first y times 1. Right? We don't say x prime because, x prime is dx dx. That's just 1. So we just get that that is x times y prime plus y. Now, derivative of x, well, that's just 1, right? Derivative of x is 1. Okay, now the hard stuff. Derivative of e to the y times sine x. Well, it's just product rule again. And we just do, well, first d last, so e to the y times, first d last plus last d first. E to the y times sine of x. What's the derivative of sine of x? Cosine x. Plus sine of x times derivative of e to the y. Well, what's that? It's just e to the y times y prime, right? Okay, and then as we do, we solve for y prime. So how are we going to do that? We're going to subtract an e to the y times cosine x. We're going to subtract an x y prime, and we get sine x e to the y times y prime minus xy prime is equal to 1 plus y minus e to the y cosine x. And now we have two y primes all on one side. We can pull them out, and we get y prime of sine x e to the y minus x is equal to 1 plus y minus e to the y cosine x. And then we just divide by sine. Sine x e to the y minus x on both sides. And we get that y prime is equal to 1 plus y minus e to the y cosine x divided by sine x e to the y minus x. And that's how you do this problem. And these are the two problems I wanted to cover. There will be more problems in the description of the video. I highly recommend that you do them because the only way you'll learn calculus is just by doing problems. So, on a final note, my lighting is kind of terrible, as I'm sure you guys have noticed on this lovely channel of mine. And I was wondering if you guys had any tips or pointers. There's like a square right here of light that I can't really figure out how to get rid of, and if I turn it off, there's not enough light on the board. So please leave in the comments or email me just any tips you guys have. But yeah, so my name was Logan. Thanks for watching. Have a great day.